The biggest thing to really understand absolute value inequalities is to understand the meaning of absolute value, and then if you access the inequalities through that way, things will really kind of fall nicely into place. So before we get into inequalities themselves involving absolute value, let's just recall that when we're dealing with an absolute value equation, like you're seeing here, absolute value of x equals 5, the meaning of what that is that whenever we're using absolute value, of course, we're referring to the distance of the quantity that is absolute valued from 0. So it's the distance of, in this case, x from 0. So how far x is from 0, and then because of the equal sign, we can see that it is going to be exactly 5 units away. And so the solution to what this would be would of course be the number -5 and 5 as the possible values for x in this particular situation, right? For us to be a distance of exactly 5 units away. So now we move ourselves into inequalities. We're going to, in this first part, just focus on when the absolute value quantity is less than or equal to a quantity, and then we'll look at the other case where we're greater than. So in this particular case right here, we have almost a similar sort of a thing in that we're looking at the distance of whatever quantity is absolute valued, so the distance of, in this case again, x. So the distance of x from 0 is what's indicated there. Now, because of the symbol less than, it is less than 5. So what that really basically kind of means in a nutshell is that how far x is from 0 has to be less than 5. So we can't be too far away from 0. We have to be within a certain distance. So from 0, we can go out as far as like 4.999, right? But we can't go to 5. But we can also go out in this realm as well. So it turns out that the entire section between -5 and 5, but I guess excluding the 5 and excluding the -5, all of those numbers there that I've indicated in that interval are going to be solutions to this. And this will make sense because, like, for example, definitely -3 is a number we could plug in for x because that's a true statement, because the absolute value of -3 is 3 and 3 is less than 5. And then also, like, that number right there is a solution for x because the absolute value of 4 is less than 5. So notice that if we picked any number that was greater than 5, so like a 6, then we would get this statement, but that statement is false, right? And then if we picked any number out here that's lower than -5, so if we picked like -7, that statement there is also false because -7 is absolute value of 7, and 7 isn't less than 5. So it turns out that the only solutions to this particular inequality that we had right here was the intervals of numbers where x is between -5 and 5, excluding the -5 and 5. Okay? All right, so with that in mind, let's just kind of look at some ones that have just a little bit more stuff kind of going inside the absolute value or outside of it. So whenever we're solving absolute value equations or inequalities, the same thing will hold here, that you always want to isolate the absolute value quantity alone on one side of the inequality in this particular case. And in this case, it is isolated because it is the only thing on the left-hand side. So we want to think about this meaning of this statement, and the meaning of this statement is saying that we've got a distance from 0, but it's of the expression 2t plus 4, and it's going to be less than or equal to 8. So just kind of thinking, like, if this is where 0 is on the number line, okay, then if this is where 8 is at, but then we also are going to have -8 right here, then anywhere in this interval right here can be where 2t plus 4 is going to be located, so that its distance is going to be less than or equal to 8 away. So what that basically implies for us is that 2t plus 4 has to be between 8 and -8 for the distance of that expression to be less than or equal to 8 from 0. So now what we've set up right here is we've set up an inequality that no longer has an absolute value involved. It's just a compound inequality that's of the AND type. And we know to solve this, we want to isolate t, which really we just need to subtract 4 and then divide by 2 to everything. So if we do that first step right there, we're going to get negative 12 is less than or equal to 2t is less than or equal to 4. And then we can divide by 2 to everything. And then that's going to give you a final result for just what the values of t are going to be. No, we never divided or multiplied by a negative, so then the symbols had to flip. And then those would be the possible values that t could be that we would be able to plug in for t in that expression and then get a true statement out of that. All right, and then this one right here, notice that we do have an absolute value with a variable contained inside of it. So if we're going to try to solve this inequality, we actually need to isolate that right there. So it's divided by 9, and then we're also subtracting 3. So the first thing that we're going to want to do to both sides of this is undo the subtracting of 3. So we'll add 3 to both sides. That's going to give you the absolute value of n plus 2. Still divided by 9 is less than 2 plus 3, which is 5. And then we're going to want to undo the multiplication by, or undo the division by 9 by multiplying by 9. So multiply by 9, and then that's going to give us then the absolute value of n plus 2 is less than 45. We multiplied by a positive 9, so the symbol did not have to flip. So what that statement means is that the distance of n plus 2 from 0, since it's absolute valued, has to be less than 45 away. So we can go as far as 45 or as low as negative 45 to be that far from 0. So because this is just a strict less than, then both of these are going to be strict less thans. They don't have equal to's. And so the n plus 2, what the value of n plus 2 is going to be between there. So now when we solve for n, all we need to do is just subtract 2 from everything. And what you're going to end up getting then is negative 47 is less than n is less than 43. Excuse me there. All right, and then just some special cases to kind of consider along the lines of less than. So this is kind of a special consideration. So the problem might start out busier and then you have to isolate an absolute value. So like now you can see that there is an absolute value that's isolated, it's all alone. So think about this, right? If you absolute value something, okay, you want it to be less than negative 3. So we know that if you absolute value something, it's always non-negative. It's either going to be 0 or positive. So it can't be negative. So is it true that what we absolute value is going to be less than negative 3? Well, then that means that this right here is always going to be negative, but it can never be negative, right? So no matter what number you plug in for x, like you're never going to get this statement to be true, right? So there's going to be no solution in this case like this, since an absolute value can never be negative. Okay, and then this is a kind of a special case right here as well. So we've isolated the absolute value quantity, and it says it's less than or equal to the number 0 in this particular case. So this aspect of it, to be less than 0, is never going to hold because you can never get an absolute value to be less than 0, but the equal part to it can definitely hold. So really, if the equal part would hold, if you're going to absolute value something and equals 0, then you need the worth of what's inside the absolute value to be worth 0. So that means since we've got 5x plus 2 in there, we want to try to figure out what x we could actually plug in. That's going to make 5x plus 2 worth 0, which means that you can just, put 5x plus 2 set it equal to 0 and solve for what that x would need to be that you could plug in. So if you just subtract 2 from both sides and then you divide by 5, turns out that x equals negative 2/5 is going to be a solution, and that turns out to be the only solution to this particular inequality, just because the only thing that we can really get this to equal for this to be true is just for the absolute value to equal 0 when x is negative 2/5.